Alright, so we're going to start talking about physical and chemical properties and changes by starting with physical properties. So a physical property of matter can be observed or measured without changing the matter's identity. So this is something we can just look at, smell, touch, something that is easily observed with our senses without that object having to actually change what it is for us to tell that it has that property. So we see physical properties every day. Everything has physical properties that mostly we can usually see pretty easily. So examples are color, strength, how flexible something is. Can it conduct electricity? What is its density? Its mass is a physical property. Is it magnetic? These are all things that we can figure out without actually having to change the object to test it. Obviously, color we can see. We can test strength with force and flexibility. We can do the same. We can easily test conducting electricity by sending a current through, which doesn't change change the identity. Density and mass we can both measure. So these are all things we're able to see, feel, touch, test, things like that without having to change the whatever that substance is that we're looking at. So density, I hope we remember what this is from measurement that we've been doing for years now, but density again is the amount of matter in a given space or volume. So if we're looking at the difference between a basketball and a bowling ball, hopefully you guys know that a bowling ball is more dense. It is approximately the same size as a basketball. Basketball is bigger, takes up more volume, but they're not too far off. But the bowling ball has a lot more density because there's more mass shoved into that bowling ball. It has a lot more matter inside, considering a basketball is hollow. So we're gonna look at density here and how to calculate, which again I hope is a little bit of a review. So looking at the densities of liquids, gases, liquids, solids, they all have a density. So a liquid that is less dense is going to float on top of a liquid that is more dense. So if you pour oil in water, a lot of times you'll notice that oil is going to float on top. That's because oil is less dense than water, so it's going to float on top of that rather than sink. So you can see with the layering here, we're going to do a bit of an activity with that up in the future, but that's the way the density of liquids work. Density of solids. So if you think about the question, which would be more dense, a ton of feathers or a ton of rocks? So think back, density, the definition is how much mass is shoved into a volume of something. So a ton is 2,000 pounds. So if we have 2,000 pounds of feathers and 2,000 pounds of rocks, it's going to take a lot less rocks to get to 2,000 pounds than feathers. So that means you're going to have the same amount of mass, 2,000 pounds, shoved into a smaller volume because you have less rocks to do that. So a ton of rocks is going to be more dense than a ton of feathers. Another thing about solids is that if it has a lesser density than whatever it's liquid it's being put in, it will float. And if it has a higher density than whatever it's put in, it will sink. So water has a density of 1. So I know that in the past we've looked at these things. We did some with diet soda cans and regular soda cans and showed the difference between what's floated and what sank. But if an object has a density more than 1, it's going to sink in water, and if it's less than 1, it's going to float in water. And then this is an equation we've definitely seen this year and 2 years before this, but so when we find density, we do mass divided by volume. So it's how much mass per volume you have. So it really just depends on what you are measuring, but some different units we have: grams per centimeters cubed, grams per milliliters, kilograms per meters cubed, kilograms per liters, and so on and so forth. So that is some of our physical properties that we will be looking at.